atoms. Well, first thing you need to know are some really basics you probably learned in earlier grades, but you have basically two parts to the atom. You have a nucleus, which is, in this fairly simple model, would be this red circle here. All right, that's the center. And then you see that you have these orbitals. This is where the electrons are going to be located. Okay, and that's what we're going to be focusing in on. Now your nucleus, all right, this red dot here, that's made up of protons and neutrons. It's actually got other subatomic particles in it as well, but that's what we're going to be concentrating on right now. Now in a stable atom, you have the same number of protons as you do electrons. Okay, and that's going to be important to remember. Okay, you still have your electrons on the outside here. Now the electrons, all right, they are traveling around. Now the electrons actually can be removed from the atom. Okay, and so what happens if you remove one of those electrons, then your atom is going to become positively charged. When you are looking at the simulations, that's something that you're going to want to remember. Okay, I have some other links that you can check out. You can check out this link here. Alright, and then under static electricity. Alright, one of the key things, work. That's going to be our next unit we're going to be studying. But work must be done to remove the electrons from an atom, which means that you're going to have to apply a force through a distance. And here are some examples here. Rubbing your feet on a rug and then getting shocked. Alright, what happens when if you do not pick up your feet and you're rubbing your feet on the rug, you were doing work on the rug and you were picking up the electrons. And basically, they're all going to you almost like ground. Okay? You're picking up all these. But then what's going to happen is you're going to get a lot of them and you're going to come in contact with something that would like the electrons. And that's when you're going to find that the electrons are going to jump, usually from the tips of your fingers. Another one is when you put clothes in the clothes dryer. Certain type of clothing, like nylon, has a tendency to be staticky. But when in the wintertime, when it's dry, there's not a whole lot of moisture in the air, you get the same thing happening as the clothes tumble over each other. You'll get static. When you put those sheets in the dryer, those static sheets, what that does is it coats the clothing so it's not as easy for the electrons to jump. So when they're jumping, what's happening is you have a positively charged item and you have a negatively charged item, and then when you pull them apart, you ever see the sparks that fly? That's static cling. But what you've done is there's actually been work done on the clothes, and electrons have moved from one article of clothing to another. Okay, now what are listed here are the two simulations that I want you to do. They're actually your next two assignments. They're very simple, very, very simple, elementary. Okay, and what you're going to do when you go to this one, you're just going to see how work can travel into, actually it's a John Travolta figure, okay, in this one. And this one is just balloons, so you can see how you're getting positive and negative charges on things. So you're going to be wanting to look at them and basically, what are you learning from that? Shouldn't be really anything new. Okay, with this one, this is actually kind of interesting. There are quite a few clips. Some very interesting ones. Take a look at those. You'll get a little bit better idea of static. They at the lab, what they do is it's their education piece that they do for the public, and there's a lot of interesting, some things I've even tried myself. So you might want to, actually after seeing them, you might want to try some of them. Okay, before we had talked about the universal law of gravitation. Well, what I would call the sister law is what's Coulomb's law. Take a look at the setup. It's force, but this time it's an electrical force. K is the constant for Coulomb's law. Okay, Coulomb's constant. Q stands for charge 1. Q2 is charge 2. And D is the distance squared. And you can see down here the units. Going to be in newtons. And look at the unit over here. Newton, meter squared, Coulomb squared. So that everything cancels out except for the newton when you multiply by these things. And this one is 9.0 times 10 to the 9th. All right. And charge for coulombs. All right. 1.60 times 10 to the 19th coulombs is for protons and neutrons, and your distance is going to be in meters. And here's an example. An electron and proton are, and they're giving you the distance here. That's going to go down here where D is. What is the electrical force of the attraction? All right, so what you're going to have here is 1.6 times 10 to the negative 19th. You have it twice for Q1 and Q2. And you have 5.3 times 10 to the 11th, which is given to you. And it looks like we're missing K. Here, we'll have to double check that those numbers are. But K would go right in here, and you multiply it by this whole thing here. And you end up getting 8.2 times 10 to the negative 8th newtons. Now, like I said, I don't remember whether that just was neglected to be put in there, or you'll have to check that out. Put that in your calculator and see what that comes out to, just as it is. See if it equals that. If not, then they did multiply by the K here. Another one, electric field equation. All right, that you would take that force that you found in the previous example and divide it by Q. Okay, now the pictures that they're talking about here are actually a book. Don't worry about that. All right, well, that wraps it up. The Coulomb's law stuff, that was just so that you could kind of see what was happening. It's a sister equation. The reason that we talked about the law of universal gravitation at the beginning is so that you can see the pattern here. That we have equations for very big things, such as planets, and we have equations for very small things, like subatomic particles, protons, neutrons, electrons. But what's really kind of strange is there's nothing in between. When it comes to our world, the technology, we could do big, we could do small, but it's the in-between that we have trouble with finding. It's probably there, but we do not have the technology to determine some of these things. Like we had talked before about attraction between a person and a chair, okay, or two people. All right, we do not have the technology to measure that yet. Okay, well, I hope you enjoy doing the video links. That's what you're going to do next. And that's all part of this week's assignment. So have a good week.